Example 3, find the inverse of the function by identifying an appropriate restriction of its domain. So the first example that I'm going to do is the function of x squared plus 8x plus 16. I'm also going to set the background to the dots here. And now I want to go ahead and substitute in y in for f of x. So instead of dealing with f of x, I'm going to substitute in for y. Y equals x squared plus 8x. Let's make that plus a little bit thicker. There we go. Plus 16. And then now I'm going to swap the x's and y's. So this becomes an x equals, this becomes y squared plus 8y plus 16. And now, in order to get y by itself, I must factor. So x equals, I'm going to go ahead and factor this trinomial. When I factor it, of course, I'm going to get two sets here. And the factor pairs of 16 that add up to 8 are going to be 4 and 4. They are both positive. Let's try that again. So 4 and 4. 4 plus 4 adds up to 8. 4 times 4 gives us positive 16. So I'm just going to plug in the y's now. And that equals x. So x equals, notice I have two of these expressions. So I'm going to go ahead and write it as y plus 4 squared. And to solve for y, or to get y by itself, I'm going to need to square root both sides because y is ultimately being squared. So the square and the square root, they cancel out, and I'm left with y plus 4 equals the square root of x. Okay, and I need to get y by itself, so I'm going to subtract 4 on both sides, and I will get the square root of x minus 4 equals y. So I'll just show you this step here. And I get this here. So y equals the square root of x minus 4. And instead of having y, I can now go ahead and substitute y with the f of negative 1x, or the inverse of x, equals the square root of x minus 4. So it's asking you for the appropriate restriction of the domain of our inverse function. Knowing what we know about radicals, we should obviously know and tell that our x values must be greater than or equal to 0. Because if not, if I have negative numbers inside a radical, that will give me imaginary. So x must be greater than or equal to 0. So that's going to be the appropriate restriction of its domain. And we can go ahead and take a look at that here. So I'm going to go ahead and draw a graph. Let's draw it down here a little bit. Let's start over. It's hard to draw on this. So I'm going to try to draw, let's see if I can do it. That's close enough to a straight line. Use your imagination. Okay. And I can create a table over here real quick of my x and y values. And so if I have the square root of x, if I were to choose 0, 0 square root of 0 minus 4 is negative 4. I'm going to choose x values in for here that when I square root them, I get whole numbers. So if I choose 1, the square root of 1 is 1. 1 minus 4 is negative 3. The square root of 4 is 2. 2 minus 4 is negative 2. If I choose the square root of 9, the square root of 9 is 3. 3 minus 4 is negative 1. And so forth. I can do 25, but that's going to be way off my graph here. And so 0, negative 4. So if this is my line here, 1, 2, 3, 4, 0, negative 4, 1, negative 3, negative 3 is right here, 4, negative 2, 1, 2, 3, 4, negative 2, and 9, 1. So 5, 6, 7, 8, 9, negative 1, and so forth. So I draw this line here. You guys get the idea. It's a half of the parabola because we start off with a parabola over here. And so our domain is restricted from x equals 0. X is greater than or equal to 0.